Hi, today we are going to talk about binary search tree. Binary search tree is a binary tree, but it has some values. And for each node, it has some value stored in that node. And it has the property that the values of the left branch of the root is always smaller than the value in the root. And the value of all the part in the right of the root has values greater than the value of the root. And the same thing applies to every subtree. For example, for this subtree, so the value of the root is 10, and it's more than the left, all the values in the left part, which is only, we have one node with 5, and it's less than all the values in the right part, which is 12, 15, 18. The same applies for the 30 and so on. So this is the binary search tree. How we create a binary search tree? Let's assume we want to create binary search tree with these numbers. So first we create the root node 45, and then we want to add the 10. So because 10 is less than 45, then 10 has to be in the left. And then we want to add 7. Because 7 is less than 45, so it has to go to the left. And it's less than 10, so it has to go to the left of the 10 again. 90 is greater than 45, so it has to go to the right. 12 is less than 45, but it's greater than 8, so it will come to the right. 50 is greater than 45, but it's less than 90, so it will go to the left of the 90. 13, it will come, it's less than 45, greater than 10, greater than 12, so it will come to the right of the 12. 39, it's less than 45, greater than 10, greater than 12, greater than 13, so it will come to the right of the 13. 57 is greater than 45, is less than 90, it's greater than 50, so it will come to the right side of the 50. So to insert an element in the binary search tree, first we start from the root and we compare the element we want to insert with the root. If it is less, then we go to the left subtree. If it's more, we have to go to the right subtree. And we continue until we reach the point where we want to add this node. So we reach to leaf node and we will add this new node as a leaf node. So let's take example. Imagine we have this tree and we want to add 2. So 2 is less than 10, so we go to the left. 2 is less than 7, we go to the left. 2 is greater than 1, so 2 has to be in the right as a new node. So this is the way how we can insert elements. If we want to search for elements, it's called binary search tree, so it's made to search for element in an efficient way. We will discuss this. So to search for an element, we compare this element with the root. If it's the same, then we are done. We find it in the root. If it's less than the root, we have to go to the left part. If it's more, we have to go to the right part, and when we repeat till we find the element or don't find it. For example, let's search for the element 12 in this tree, binary search tree. So we start with the root. 12 is greater than 10, so we go to the right. 12 is less than 15, so we go to the left. And then we compare 12 with 12. We find that this is the node that has a 12. And now to implement this binary search tree, it's very similar to the previous tree, what we implement. It's just we change that data now is not an object, it's just integer. And the constructor accepts integer and it's assigned it to the data. Binary search tree is the same. We have a special node called root in the binary search tree class, and then we want to add in this class the operations. So we can insert element. To insert element, we use recursion again. So we have public node, insert recursion node. We define the root nodes and the value we want to add. If the root node is null, we just create new node with this value and add it. Else, if the data in this node is less than the key, then we have to add this key in the right place. So we do insert recursion. We call the same method, but not with the root, with the right child of the root. So we try to add it in the right part of the root, because the value is greater than the value in the root. And then we return in. Else, we try to add it in the left part of the root. Okay? And then we return in. And this is the so this is the helping method, and then we can make public void insert key, and we call this method for the root. So this method will insert the node in the correct place. We can also have a method called search. So again, we will use recursion. So if we want to search for a key in a tree that has a root, so if the root is null, all the root data is the same as the key, we stop, we return the root. So if we find this, if the root is null, we return null. If we find the key in the root, then we return the root. Okay. طيب. If the root data is less than the key, this means the key should exist in the right part. So we call this method for the right subtree of the root. So root.right. Else, we call it for the left part. And again, it's a recursive method. So the main method will be public node search and key return search for the root. So this method, we don't tell the root, we just say we are searching for a key, but here we are calling this method with the root. So if you want to test like the tree, we can create this tree. So this will create 45 as a root, and then if we insert 10, it will add 10 here. If we insert 7, it will add 7 here to the left of the 10. 12, it will be here. 90 will be here. And 50 is greater but less than 90. If we want to search for 7, the algorithm will try to search here. 7 is less than 45, it will come here. 7 is less than 10, then it comes here, 7 equal to 7. So this will return this node. So this node n will be pointing to this 7. If I print the data, it will print 7. If I try to print this tree in order, so I will get it like this. If you remember, in order 7, 10, 12, 45, 90, and 50. Now as exercise, you need to implement the binary search tree. You need to test this tree by inserting these numbers, and you need to print the tree using in order traversal, maybe also post order, a pre-order. And also the last exercise, write a method to find the maximum value of the binary search tree. Thank you for listening.